Here we have a geometry problem. Okay, let's go with the question. There is a figure given here. In the figure above, angle measure A and angle measure C are congruent. That means they are equal in measure. So the line segment BD bisects AC. That means the line segment BD divides AC into two equal parts. That is the length of AD and the length of DC must be equal. That is D is the midpoint. Already we know the length of AC, that is 14 units. So if BD bisects AC, that is BD divides AC into two equal parts, then the length of AD is 7 units, the length of DC is 7 units. Okay, so we have to find the perimeter of the triangle ABC. Okay, so for that we have to know all the three sides, lengths of all the three sides of the triangle ABC. So when I add the lengths of all the three sides of the triangle ABC, I can get the perimeter of the triangle ABC. Okay, already you know the length of the side AC. So I have to find the length of BC and I have to find the length of AB. And also one more thing we have to consider in this triangle ABC. So the sides AB and BC are opposite to the angles which are equal in measure. So whenever two angle measures are equal in a triangle, the sides which are opposite to the equal angle measures must be equal in length. So the length of the side AB and the length of the side BC must be equal because they are opposite to the angles which are equal in measure. Okay, once I get the length of BC, I can take the same length for AB and I can find the perimeter of the triangle ABC. Okay, now let's consider the line segment BD over here. It is drawn from one of the vertices to the opposite side AC and also it bisects the side AC. So whenever I draw a line segment like BD between two equal sides of a triangle and also if it bisects the third side, then the line segment BD has to be perpendicular bisector for this AC. That means already we know that BD bisects AC and also this line segment BD will be perpendicular to the line segment AC. Okay, now we have two right triangles. Okay, now let me consider the right triangle BCD. So in this right triangle BCD, I know the length of two legs BD and CD. So I have to find the length of the hypotenuse BC. So BC is the side which is opposite to right angle. So BC is considered to be hypotenuse. So we can use Pythagorean theorem. So the Pythagorean theorem says that the square of the hypotenuse, that is BC square, equals to sum of the squares of other two legs, that is BD square positive DC square. Okay, so for BC I do not know the length, so I have to keep BC as it is. For BD I know the length, it's 4 times square root of 2. So we can plug in 4 times square root of 2 for this BD, then we have 4 times square root of 2 the whole square, and for DC we have 7, then we get 7 square over here. So BC square equals to, here 4 and square root of 2 are multiplied and we have the common exponent 2. So whenever two quantities are multiplied and we have the common exponent, the exponent can be taken separately for each quantity and multiply them. Then I'm getting 4 square times square root of 2 the whole square, and the value of this 7 square is 49. Okay, so BC square equals to, the value of 4 square is 16, and this square root and square root cancel out, 16 times 2 positive 49. So BC square equals to 16 times 2 is 32 positive 49. So BC square equals to, when I add 32 and 49, I am getting 81. Okay, so but I need the length of BC. Okay, so for that I have to get rid of the square. So for that I am taking square root on both sides. When I take square root on both sides, the square will cancel out, and BC equals to, so when I take square root for 81, I am getting 9. So when I take square root for a number, in front of the result, usually we consider positive or negative. But here BC represents one of the sides of the triangle, so it can never be a negative value. So in this positive or negative, we can consider only the positive sign. So anyways, so the length of BC is 9. Then what is the length of AB? So it should also be 9 because already we have discussed AB and BC are opposite to the angles which are equal in measure. So they must be equal. I mean the length of AB and the length of BC must be equal. Since the length of BC we got 9, the length of AB also must be 9. Okay, now what we can do is we can find the perimeter of triangle ABC. Okay, let me finish writing perimeter of triangle ABC. That's the target of the question. So to get the perimeter of the triangle, I have to add the three lengths, the lengths of the three sides, AB, positive BC, positive CA. So the length of AB is 9, the length of BC is 9, the length of CA is 14. So 9 positive 9, 18, 18 positive 14, 30, 2. So the perimeter of triangle ABC is 32 units. I find 32 in option A. The correct answer choice for this question is option A.